All right, this final way of factoring here should be very familiar just because it looks very similar to when we factored with having a coefficient in front, that a value being bigger than 1. What we're going to do in these problems is we're going to start by looking at two different groups. This group first, here I'm highlighting in white, and then this second group here, which I'm going to do in blue. For the part that's in white, what I need to do, the part that's boxed, what can I pull out? What do they have in common? Well, they have a 2 in common, and they have an x squared in common. When I pull that out, what am I left with? I'm left with a 3x and a minus 8. When I look at the second part, what can I pull out in the part in blue? I can pull out a 7, and that leaves me with a 3x minus 8. And again, this should look very familiar because we have two terms that are left behind. They should be the exact same. That's one of your factors. The two terms that were pulled out, the 2x squared plus 7, becomes your other factored term. So this is how you factor by grouping. Let's look at another example. Same idea. Take this first part, box it. Take this second part and box it. And see what we get in each. With the first part, I'm going to pull out a 7 and an x squared. This will leave me with a 7x minus 5. And then for the second part, I can pull out here an 8. When I pull out an 8, I'm left with, again, 7x minus 5 as I want it. So, again, my two parts that are left behind is one factor, 7x minus 5. And the two parts that were pulled out become my other factor by 7x squared plus 8. All right, this last time, something to watch out for as well. I'm going to box my first set like we always have, box my second set just like we've done before. What can I pull out? Well, there's no number I can pull out here, but I can pull out an x squared. When I do that, I'm left behind a 2x plus 5. In the second term, I can't pull anything out either, so I'm going to pull out a 1. However, I do want to get rid of this negative in front of the x. We don't like that, so I'm going to pull out a negative 1 instead, and again leave me with 2x plus 5. Now, again, same as we've done before, we have a 2x plus 5 that's left behind from both of them. And what I pulled out was an x squared minus 1. Now here's the kicker. You always have to check and see, can I factor these anymore? My linear part, I never can factor. This one right here, though, might still be able to be factored. And in this case, I can break this down even more. I can look at this and say, well, I have x squared minus 1, so the perfect square binomial. They're a difference of squares. So I have an x minus 1 and an x plus 1 for that part. And I still have this other term, 2x plus 5 in front. So always check this part here that's squared and make sure that you can't break it down and factor it anymore.